is my favorite prime number of all time. There are a lot of classes of prime numbers, such as Gaussian primes or Eisenstein primes, but most notably, 67 is a Chen prime, which is my surname. I'm James Chen. So Chen Jinren in about 1976 or something founded Chen primes and discovered Chen's theorem. So a Chen prime is a prime P such that P plus 2 is either a prime or a semi-prime. And a semi-prime is a number that has exactly two distinct prime factors. So 67 is a prime. You cannot find any integer that's not 1 or 67, divide 67 exactly. P plus 2 is 69, which is not exactly a prime number because it is 3 times 23. But because 3 and 23 are prime numbers, 69 cannot be decomposed further into a product of primes. And since it has exactly two distinct prime factors, 69 is a semi-prime, and so is 67. It's a Chen prime. And in 1976 or whatever, Chen proved that there is an infinitude of Chen primes. If you're taking A-level maths or further maths, you might be familiar with the proof of the infinitude of the primes. But the infinitude of the Chen primes is much harder to prove, so I won't do it. So this is actually important, believe it or not, because the Twin Prime Conjecture, which is one of the most famous unsolved problems in mathematics, conjectures that there are an infinite number of primes which are 2 apart. So if you imagine that 69 is y prime, which it isn't, then 67 and 69 would be twin primes, and basically. And nobody knows if there is an infinite number of twin primes. But what Chen Jinren managed to do was prove that there are an infinite number of Chen primes. So it's almost like 1 plus 2 instead of 1 plus 1. So because this number is prime, and the number 2 more than it is semi-prime, so it has 2 distinct prime factors. And the Twin Prime Conjecture just wants to bring that 2 down to 1 to say that there are an infinite number of pairs of primes that differ by 2. And anyway, Chen's theorem, which is related to Chen primes, but not exactly the same, states that every sufficiently large even integer can be expressed as the sum of a prime and a semi-prime. So, when I say sufficiently large, there is a certain number, which I don't know off the top of my head, even though I know 200 digits of pi for some reason, so that even integer is greater than this number. If it is greater than this number, then it must be able to be written as the sum of a prime and a semi-prime in some way, which gets us really close to proving the Goldbach Conjecture, which states that every even integer can be written as the sum of 2 primes, which is related to this 1 plus 2, 1 plus 1 theme of a prime plus a semi-prime, which Chen Jinren, my goat, managed to prove. But 1 plus 1, a prime plus a prime, we can't do yet. And Chen Jinren proved, somewhat coincidentally, that this thing, which I am not going to explain, C the 1, 2, is greater than or equal to 0.67 x c x over log x all squared. Now you're going to have to trust me on this. I have not made any of this up, by the way, contrary to what you might be believing. And yeah, so like Chen Jinren was a legend, and my parents, one of which who does not like maths at all, has even heard of him. He's probably one of the most famous Chinese mathematicians of all time. He published 66 papers in his life, which is ridiculously annoying, for obvious reasons. But yeah, what can you do about that? So yeah, 6, 7.